In this module, we will cover the observer pattern. Its intent is to define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. It's also known as publish-subscribe or pub/sub. We will start by describing the pattern using a real-life example. As a real-life example, we will use part of a ticket management system in which services have to communicate with each other. We will map that to the structure of the observer pattern and will implement it in a demo. We'll continue with learning about the use cases for this pattern, pattern consequences, and related patterns. Let's continue with describing the observer pattern. The observer pattern is a behavioral pattern from the Gang of 4 library of design patterns. The intent of the observer pattern is to define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. It's a pretty common pattern. For example, in Angular you've got an observable class that implements it. Also, when you're working with microservices, you'll often have services that subscribe to change events on other services to allow them to keep their data store in sync, and so on. What we will use as an example is part of a ticketing management system. It exposes a bunch of services, all with their own data store that needs to be kept in sync, not unlike what you'd expect in a microservices architecture. For example, there's an order service that has a notion of a set of tickets for a certain artist. When the order is fulfilled, the tickets are no longer available and it updates its data store. But our system knows of other services as well. There's a ticket stock service, which needs to be notified of the fact that the tickets are no longer there so it can update that in its data store. And then there's a ticket reseller service, which also needs to be notified of the fact that the tickets are no longer available. Other services that need to know about this can exist as well, but we'll leave it at this for the example. In any case, we are dealing with a system in which a set of related objects, which are our services, need to maintain consistency. We can easily achieve that. We could simply store a reference to the ticket stock service and ticket reseller service on our order service and let the order service call methods on them to notify them that the tickets have been solved. The problem is that that would introduce tight coupling. It would also become quite complex to manage once the amount of services that need to be notified start growing. And moreover, if we don't know in advance how many or which services need to be notified, this won't work at all. Enter the observer or pub/sub pattern. We'll start with a base class, a ticket change notifier. Our order service will be a subclass of this. On the ticket change notifier, we implement methods to add and remove observers, and also want to notify them. We won't add, remove, or notify concrete observers though. We'll also work on an interface, say iTicketChangeListener. So it's this interface that's implemented by our observers, the ticket stock service and ticket reseller service. The interface defines one method, receive ticket change notification, with the change in tickets as a parameter. What happens now is that our two observers are added as observers on our order service. The order service itself is a concrete implementation of the ticket change notifier. It calls into the methods defined on that, but next to that it also holds its state. For example, the data store containing the information it has on tickets. Once a sale happens, the order service adjusts its state by updating its data store. It then notifies all observers of this change through the notify method on its base class. And that method runs through all observers and calls receive ticket change notification on them. Like that, each concrete observer can update its own state accordingly. So that's how this works. Now let's map this to the pattern structure. The first player in the pattern structure is the observer. That's our iTicketChangeListener. It defines an updating interface for objects that should be notified of changes in a subject. And that subject, that's our ticket change notifier base class. It knows its observers. Any number of observers can observe a subject. Next to that, it provides an interface for attaching and detaching observer objects. The concrete observer maps to our ticket stock service and ticket reseller service. These store state that should remain consistent with the subject state, and they implement the observer updating interface to keep its state consistent with the subjects. Lastly, the concrete subject stores state that's of interest to concrete observer objects, and it sends a notification to its observers when its state changes. That's the order service from our example. And there we go, that's the pattern structure. I do want to mention something here. The diagram you see on screen now slightly differs from the original pattern template. In our implementation, we're passing through the state from concrete subject to concrete observer as a parameter via the notify method. In the original template, the concrete observer would hold a reference to concrete subject, so it could query it for state changes. That's a valid implementation as well, but these days the one we detailed is more common. In any case, the intent remains the same, and as already mentioned a few times in this course, that is what's important, not the exact implementation of the template. Let's continue with a demo. In this demo, we'll implement the observer pattern, and we're going to start with a helper class, ticket change. This will hold the state change information that needs to be sent to observers. For example, a ticket change for artist with ID 1 and amount 2 means that 2 tickets have been sold for this artist. It's an object of this type that will be received by observers. Then let's add a subject. That is our ticket change notifier. It's an abstract class. We don't want it to be used on its own because it doesn't contain the state information observers want to be notified about. That is contained in the concrete implementation. What this does contain is a list of observers, and those are objects that implement iTicketChangeListener. We haven't defined that interface yet, so let's do that next. Like that, our code will resolve again. And there we go. It's named iTicketChangeListener, and this is our observer. It contains just one method, receiveTicketChangeNotification, which is used by the subject to notify its observers about a change in the amount of tickets. Then we can start adding methods on our ticket change notifier. We need a few methods to manage observers. After all, it is the ticket change notifier that needs to keep a list of observers it needs to notify. So we call into addObserver, which accepts an iTicketChangeListener as parameter. When the method is executed, the observer gets added to the list of observers. RemoveObserver removes an observer from the list. And when notify is called, all observers receive a ticket change notification with the ticket change object passed through as parameter. That's it for the abstract class. On to the concrete implementations. Our subject is the ticket change notifier, and we're going to start with the concrete subject, which is our order service. It subclasses the subject, the ticket change notifier. What this class is concerned with is its state. For all registration and communication related tasks, it relies on its base class, the ticket change notifier. We're going to add one method to it, complete ticket sale. It's this method that is called by clients when a ticket sale is completed. That means that at this moment, the order service must update its state. It must update its data store so the correct amount of tickets for the correct artist is deducted. For demo purposes, we'll assume that when we see an order service is changing its state message, that the local data store is adjusted. After that, it calls the notify method on its base class, the ticket change notifier, to notify the observers. And with that, we've got our concrete subject. The last two parts of the pattern are the two concrete observers. The ticket reseller service is our first one. It needs to implement the iTicketChangeListener interface. That forces us to implement the receive ticket change notification method. This gets a state change from the concrete subject passed in, and that is the ticket change object. Thanks to the info it gets from that object, it can adjust its own data store accordingly. Our last concrete observer was the ticket stock service. This too receives a ticket change notification, allowing it to update its data store. And that's it for the pattern implementation. Now let's write a bit of code to test this. First of all, we new up our 3 services. For that, we need to import the observer namespace. So we've got our 2 concrete observers and we've got our concrete subject. To that concrete subject, we add these 2 observers. For that, we can call add observer on the order service. As a parameter to add observer, we need to pass through something that implements iTicket change listener, and both our ticket stock service and ticket reseller service do. Then let's say that a ticket sale happens for the artist with ID 1. Registering such a ticket sale on the order service means calling the complete ticket sale method, passing through 1 as ID for the artist and 2 as the amount of tickets. This call should result in both observers being notified of this. Let's give that a try. Let me just add a read key statement here, and there we go. And that seems to work just fine. Order service is changing its state, after which it is notifying its observers, and then we see messages from our observers who are being notified of the ticket change. So far, so good. The nice thing here is that we can manage all of this at runtime. We added the observers at runtime. That means we can also remove them. So we remove 1 observer, the ticket reseller service, and then we complete another ticket sale. Let me add a console.writeLine statement here. That makes it a bit more readable. And let's give this another try. And there we go. The first 4 lines being written out to the console output window remain the same. After that, the ticket reseller service observer is removed, and that results in only the ticket stock service being notified of the new ticket sale. And with that, we have successfully implemented the observer pattern. Let's have a look at some use cases for it.